Hello, good morning to everybody. At present, I'll start a new lesson called Dual Nature of Light. Dual nature of radiation and matter. Dual nature of radiation and matter. This is the new topic, and is also very important in competitive examinations and also IP point of view. Compulsory there is a question for mains examination and one question for advanced level also. In NEET also there are two questions asked frequently, MCET as well as in NEET. So that's why it is very important and also theoretical concept. So my dear students, the next week examination syllabus is diffraction, polarization, and also dual nature of light up to photoelectric effect. So the sums in photoelectric effect cannot be concluded in this video. In the next video, I will complete the total photoelectric concept and also you made some problems. Right now? Okay. Here, in the name dual nature of radiations and matter. Dual nature of radiation. Radiation means light. Radiation means light. Again, in case of interference and also diffraction or polarization, light will be treated as the wave nature. Interference means superposition of two light waves. Diffraction means bending of light ray at the edges of the obstacle and encroaches within the geometrical shadow. Polarization also explains the transverse wave nature. That means the radiation or light that will behave like the wave nature as in case of wave optics. Again, in some topics, in the explanation of some topics like photoelectric effect, the same light will be taken as a particle nature. Same light behaves like a particle nature. So, to explain the interference, diffraction, polarization, light should be behaves as a wave nature, and to explain the photoelectric emission or photoelectric effect, same light will be treated as a particle nature. That means sometimes light will behave like the wave nature and some other times it will behave like the particle nature. Right. In case of matter also, matter means whatever it may be. Suppose it is a pen or paper, whatever it may be, electron, proton, all this is considered as a matter. Suppose matter means originally it has a particle nature. Originally it has a particle nature. But the same particles like electrons, protons and neutrons, sometimes they are also behaves like the wave nature. This experiment means how the electrons behaves like the wave nature. This can be proved by using Davison and Germer experiment. Later I will explain it. So that's why light particles, the light shows wave nature as well as the particle nature. It is called dual nature of light. And material particles like electrons or protons or neutrons, generally they are particle in nature, but sometimes they will also behave like the wave nature. That wave nature characteristics of the electrons can be explained in the Davison-Germer experiment. So this is also dual nature of matter. It is the dual nature of light. Right? Next one, what is meant by free electrons in a metal? What are free electrons in a metal? Free electrons. Suppose in case of atom, the total positive charge will be concentrated at the center called nucleus. It is the nucleus. Within the nucleus there are positive charged protons and chargeless neutrons. Around the nucleus, negative charged electrons are revolving in the case of circular orbits, or in the sense of circular orbits. Suppose maybe this is taken as the valency orbit, valency state. The electrons which are lying in the outermost orbit, they are feebly attracted towards the nucleus because nucleus is having the positive charge. Electrons are having the negative charge. That's why the electrons lying in the outermost orbit, they are loosely bound with the protons or loosely bound with the nucleus. That's why these electrons may move about in all directions or freely throughout the lattice of the positive ions. Say this electron may be moving like this. There is a positive lattice is created inside the given in the presence of the vacant position of the electron. So that's why this is the positive lattice. This positive lattice may be filled by the electron coming from the successive atom. That's why all these electrons may move from one atom to other freely through the positive lattices. So such a loosely bound electrons are called as the free electrons. All the electrons which are lying in the outermost orbit, they are loosely bound with the nucleus. Now these electrons are called as the free electrons. Are you understand? Right. Next one, for example, this is the loosely bound electron. There is some force of attraction towards the given nucleus. That means this electron and this nucleus, they are bounded with some energy or interactive energy. Let the interactive energy between the electron and also proton or electron and also nucleus is equal to, suppose it is 1.5 electron volt. 1.5. For example, now our aim is to remove the electron from this given atom. So to remove this electron from the nucleus attraction, the minimum amount of energy supplied to the electron is equal to 1.5 electron volts. Are you understand? Suppose if the electron in the outermost orbit is given only 1 electron volt, this electron cannot separated from the nucleus attraction. To move the electron within the boundary of the given nucleus, minimum amount of energy supplied is equal to 1.5 electron volts. This is called as the work function of the metal. Work function means the minimum energy given to the valence electron to just remove the nucleus attraction is called as the work function. But in general, work function depends only on nature of the metal and also condition of its surface. The value of work function is equal to approximately 5.65 electron volts in case of platinum, and also W is equal to 2.14 electron volts in case of cesium. So that's why in which case the electron can easily taken out from the nucleus attraction, only in case of cesium. Minimum energy supplied to the valence electron in case of cesium is 2.14 electron volt to just remove the nucleus attraction. But it is not possible to remove the electron in the outermost orbit in case of platinum also, because it requires a more amount of energy. Okay na? So what is meant by work function? The minimum energy given to the valence electron to just remove it from the nucleus attraction is known as the work function. That is represented by W. But here there is one unit EV. EV means electron volt. Electron volt is the unit for energy, and in general work or energy, SI unit of work or energy is equal to joule. CGS unit of work or energy is equal to erg. These are the general used units in case of work or energy. But the smallest unit of energy means the energy of the elementary particles. Elementary particles means electron, proton, neutron, and also they are very minute particles. Energy of that minute particles is also very, very, very small. That small amount of energies will be representing in the form of EVs, electron volts. So, electron volt is the smallest unit of energy. And what is the biggest unit of energy? Biggest unit of energy is equal to kilowatt hour. Kilowatt hour, biggest unit of energy. Smallest unit of energy is equal to electron volt. And 1 electron volt is equal to how many joules? 1.6 into 10 power minus 19 joules. 1 electron volt is equal to 1.6 into 10 power minus 19 joules. But exactly 1.602 into 10 power minus 19 joules. So this is a unit for energy of the small particles or elementary particles. Again, what is meant by electron emission? What are the types of electron emissions? Electron emission పేర్లోనే ఉంది. Electron emission means electrons are removed. The process of removing the valence electrons from the given metal is known as the electron emission. So the process of emission of electrons from a metal surface is known as the electron emission. But in general, this electron emission is of 4 types. First one, thermionic emission. Second one is field emission, or it is also called as the cold cathode emission. Third one is photoelectric emission, and fourth one is secondary emission. So these are the methods used to produce the electron emission from a metal: thermionic emission, field emission or cold cathode emission, photoelectric emission, and also secondary emission. So in this, what is meant by thermionic emission? Suppose it is a filament of the electric bulb. It is the filament of the electric bulb. Now, a current is made to passing through the filament. Positive and negative potential, negative polarities. I is the current passing through the filament. Filament is also offers some finite resistance so that the power utilized or the work done in heating the filament is equal to, in heating the filament, due to resistance, there is some energy should be required to heat the filament. That energy or work done is equal to P into T, power into time. Power is also equal to I square into R into T. So derivation no need for us. When the current is passing through the filament bulb, the filament is heated. Filament heated means some heat energy supplied to the filament, and also that energy is sufficient to remove the electrons from the filament metal surface. Okay na? ఇలా హీట్ చేసినప్పుడు some electrons will be ejected out from the metallic surface in case of the filament. Therefore, this type of emission of electrons when it is heating is known as the thermionic emission, and the electrons emitted in this case are known as the thermions. So how do we define exactly the thermionic emission? The process of emission of electrons from a metal surface when it is heated is known as the thermionic emission, and the emitted electrons are called as the thermions. Okay na? Right. Next, second one is field emission. FIELD, field emission. Field emission means, suppose the same metal which is kept in the high electric fields in the order of 10 cube to 10 power 8 volt per meter. This is the strength of the electric field. So when the metallic surface is placed in the electric field whose strength is very large, so that later electrons are emitted from the metallic surface. These type of electrons emitted are called as the field emission or cold cathode emission. Cold cathode emission. Right? And the third one is photoelectric emission. Photoelectric emission. Suppose here this is a metallic surface. It is the metallic surface. This metallic surface is having so many number of free electrons. These are the free electrons. Suppose a light of sufficient frequency or sufficient wavelength is made to incident on the metallic surface. Later, this electron will be emitted out from it. So, when a light of sufficient energy or sufficient frequency or sufficient wavelength is made to incident on the metallic surface, later the electrons are ejected from the metallic surface. This process of emission of electrons from the metal is known as the photoelectric emission, and the electrons are called as the photoelectrons. So, what the definition? When a light of sufficient energy or sufficient frequency is made to incident on the metallic surface, later electrons are ejected from it. This phenomenon is called as the photoelectric emission, and the electrons are called photoelectrons. Here the energy of the incident photon is equal to E is equal to h nu, or it is also equal to nu is equal to c by lambda. Equal to c by lambda. So this type of emission of electrons is known as the photoelectric emission. Okay. Next, the fourth one is secondary emission. Secondary emission very simple. And suppose this is the metallic surface. Suppose a fast moving electrons. Here this incident light is not electrons. Incident light is incident in the form of photons. Photon. Ikkada matram when high energetic electron beam whose energy is equal to half m v maximum square. A high energetic electron beam is made to incident on the metallic surface. Later, electrons are ejected out from the metallic surface. That means the total energy of the electrons or a fraction of energy is given to the electrons lying in the valence state, so that after absorbing this energy, valence electrons are ejected out from the metallic surface. This type of emission of electrons is called as the secondary emission. Okay, now secondary emission. So out of all these four, we will concentrate only what is meant by photoelectric emission. This is the most very important case. Right? So, in case of photoelectric effect, light may be incident on the metallic surface in the form of particles called photons. Okay, now. So now let us explain the photon picture of electromagnetic radiation and also properties of photons. So this photoelectric effect can be explained in terms of the particle nature of light. Okay, now particle nature of light. The particles are called as the photons. They are also called as the wave packets and also called as the energy packets, are also quantas. They are incident on the metallic surface. Later electrons are ejected from it. That's why the light in this case will be treated as a particle nature. Now what are the properties of these particles or photons? First one, in the interaction of radiation with matter, radiation behaves as it made up of number of particles. This radiation is made up of number of particles which are called as the photons. Second one, all the photons emitted by the source, they travel through the free space with the speed of light. Speed of the light is equal to 3 into 10 to the power 8 meter per second. Means photons travel with a speed equal to velocity or speed of the light in air medium. Third one, energy of each photon is equal to E. E is equal to h nu. Where h is equal to Planck's constant. Again, in waves, velocity v is equal to n lambda. Velocity of the wave v equal to n lambda. Here, velocity of the electromagnetic wave is equal to c, frequency represented by nu into lambda. From this, nu is equal to what is it? C by lambda. Therefore, energy of the each photon is equal to h into c by lambda. Here, h is equal to Planck's constant. Its value is fixed. H is equal to nearly 6.6 into 10 power minus 34 joule second, and velocity of light c is equal to 3 into 10 to the power 8 meter per second. So this is the formula for energy of the photon E is equal to h nu or hc by lambda. ఇప్పుడు for example, energy of the photon E is equal to h into c by lambda. What is the value of h? 6.62 into 10 power minus 34 into c is equal to 3 into 10 to the power 8 by lambda. Suppose if lambda is in meters, total energy of the photon will be represented in joules. So energy of the photon is equal to this value 6.62 into 10 power minus 34 into 3 into 10 power 8 by lambda in meters, total value in joules. How do you convert this value in electron volts? This is equal to 6.62 into 10 power minus 34 into 3 into 10 to the power 8 by lambda into, again 1 joule is equal to, what is the relation between electron volt and joule? Electron volt and joule is 1 electron volt is equal to 1.6 into 10 power minus 19 joules, or 1 joule is equal to 1 by 1.6 into 10 power minus 19 electron volts. Therefore, here it is in joules. In electron volts means dividing this 1.6 into 10 power minus 19, this total value represented in electron volts. So by simplifying this, we will get approximately this is equal to 12,400 by lambda electron volts when lambda represented in angstrom units. This is very important relation. While doing the problems, keep this shortcut method. Energy of the photon is equal to h nu or hc by lambda. It's nearly equal to 12,400 by lambda electron volts when lambda represented in angstrom units. Okay na? This is energy of the photon, incident photon. Energy of the incident photon. Next one, according to properties of the photons, the next property is the frequency of the